Welcome to Night Chemistry. Good evening, curious dreamer. Allow yourself to settle quietly, as if the night itself were drawing a soft curtain across the bustle of the day. In this calm space, a single lamp glows on an old wooden desk, its circle of light revealing a leather-bound journal and a scattering of polished wooden spheres. They wait in silence, patient reminders that even the vast and restless world is built, at its smallest scale, from simple parts. Tonight, those silent spheres will guide our visit with John Dalton, the self-taught Quaker schoolmaster who dared to imagine that air, water, and stone are woven from countless invisible units, atoms that dance, combine, and part with mathematical grace. Picture the cool mists rolling over England's Lake District in the late 18th century. A boy named John rises before dawn, slipping outside with a homemade thermometer bound to a stick. He records the temperature, notes the wind, then folds the page of his weather diary with quiet satisfaction. To those around him, these morning rituals seem quaint. To John, they are a doorway, each entry a small, deliberate step toward understanding how nature keeps its own precise ledger. Years pass, and that sturdy boy becomes the village's young schoolmaster, teaching arithmetic by day and sketching clouds by candlelight once his pupils return home. He walks the same hills he studied as a child, composing questions for the sky. Why does the dew form on one morning and vanish on another? Why does a balloon rise while a stone sinks? His notebook swells with neat columns: temperature, barometric pressure, rainfall, numbers that promise a hidden order beneath the changing weather. Yet there is more than air and rain crowding his thoughts. John sees colors differently from most, puzzling over the scarlet waistcoats that look a muddy brown to his eyes. Friends tease, but he answers with experiments, tinting glasses and examining petals until the strange condition submits to careful description. Where many would hide, he transforms personal limitation into scientific clue, adding the phenomenon, soon called Daltonism, to the growing map of the natural world. When opportunity draws him to the thriving industrial city of Manchester, he carries his weather gear and a mind sharpened by solitude. The clatter of looms and the pulse of steam engines echo through the brick streets, yet in a quiet laboratory above the city he hears another rhythm: gases pressing against glass, volumes expanding in precise ratios, invisible particles obeying laws no eye can see. He fills bladders with mixed air, measures their pressures, and asks a bold question. Could every gas be an assembly of tiny solid spheres, each kind with its own weight, its own character, its own role in a grand chemical choreography? Night after night, wooden balls roll between his fingers, standing in for oxygen and hydrogen, nitrogen and carbon. On a slate board he chalks tidy circles, squared square, inventing a simple language so that the unseen may be spoken of with clarity. Water, he writes, is not a mysterious fluid bound to earth and sky, but a union of two hydrogen atoms embracing one of oxygen. Ammonia, carbon dioxide, nitrous oxide. Each substance reveals its proportions, and in those proportions John hears the soft cadence of nature counting whole numbers. Critics frown, for the world has never touched an atom. How can one build a theory from entities smaller than sight? Dalton replies without fanfare. The numbers speak. If 3 measures of hydrogen unite with one of nitrogen, and the mass relations are always the same, then some indivisible unit must be trading places, balancing scales with perfect consistency. He trusts the ledger he began as a boy beneath Cumbrian clouds, and step by step, the ledger leads to atoms. Tonight, while you listen, imagine those atoms glimmering like lanterns in the dark. Countless, restless, yet moving to patterns older than mountains. Let the steady beat of their imagined motion guide you through calm valleys of thought. Each moment of our story, from quiet village to bustling city, is another clue left by a man who found grandeur in the smallest things. Stay with John Dalton now, and feel the hush of recognition as a world once blurred into mystery resolves, at last, into a tapestry of tiny, enduring spheres. Settling under Cumbrian skies. Night drapes itself across the fells of northwest England, and the small village of Eaglesfield lies quiet beneath the slow-turning constellations. A single cottage window glows with lamplight, and inside, 12-year-old John Dalton closes a battered primer on arithmetic and listens to the hush between ticking seconds. The hearth has ebbed to embers. The house, like the village, seems finished with the day. Yet John's pulse is bright with intention. He lifts a woolen cloak from a peg, slips his weather diary under one arm, and steps outdoors into air so cool it trembles the breath. The lane is silvered by moonlight. To one side stands a dry stone wall, to the other a meadow still glistening with dew. Sheep murmur somewhere in the dark, shifting their weight. An owl cuts a pale line above the hedgerow, silent as thought. John loves these hours before dawn, when everything that grows or bleats or rustles appears to hold its tongue, leaving room for questions. Why does dew gather on some mornings and disappear on others? Why does the same wind feel warm in June yet knife-sharp by November? He has resolved to keep a faithful ledger until the answers come. At the wall's corner he unfolds a handmade thermometer, a narrow glass tube bound to a yardstick with twine. He waits until the mercury steadies against the moonlight and notes the reading. 41 degrees by his father's old scale. A fingertip of mist coils at his boots, thin as pipe smoke. He writes, temperature before sunrise, cool and damp. Dew heavy upon grass. Wind slight, quarter northwest. The page is ruled with tidy columns, each entry another stitch in the fabric of a lifelong pattern. Returning, he pauses to taste the air as if it were broth. A hint of peat, a memory of distant rain. Clouds drift high and ragged, catching stray moonbeams that break apart like breath on glass. He closes his diary, presses the leather cover to his chest, and feels the small, certain weight of numbers already gathered there. Later, at his desk, he will copy the figures into cleaner script, add them to yesterday's totals, and imagine invisible threads sewing one dawn to the next. Inside, the house creaks as though acknowledging his return. He replaces the cloak, settles at a scarred pine table, and opens a second notebook, this one devoted to curious observations that refuse to fit tidy columns. He remembers the way a child in class asked why steam from a kettle sometimes hugs the spout and sometimes spirals skyward. He sketches a kettle, arrows showing eddies of warm and cool air, then writes a single sentence beneath. Perhaps the invisible parts of air are lighter or heavier according to heat. The thought is no more than a seed, but he turns it over, seeing in his mind small particles shifting position like dancers changing partners. Quaker teachings have raised him to prize plain speech and honest work. He will live most of his life in modest rooms, eat bread and cheese without complaint, and greet every new puzzle with the same humble salutation. Let us examine the facts. Yet there is poetry in him too, born of fells and fog. When he finishes copying the kettle diagram, he pushes the notebook aside and lets his gaze wander to the window. Beyond the pane, stars burn with indifferent steadiness, and he wonders how far they truly lie. Thousands of miles, millions. He cannot know, but he suspects the gulf is bridged by laws no less orderly than the numbers in his diary. The lamp gutters. A wisp of smoke rises, and he trims the wick with an iron snuffer. Its scent, a faint mixture of tallow and brass, reminds him of the small experiments he performs in this room when lessons are finished. Sometimes he captures rainwater, leaves it to evaporate, and measures the residue. Sometimes he weighs small stones before and after drying them at the hearth. Even failure pleases him, for it teaches restraint. Results that do not meet expectation merely ask a sharper question next time. He lifts the diary once more, reciting the latest figures under his breath the way other boys might recite psalms. In those numbers he hears the low hum of consistency. Today differs from yesterday by a single degree. The wind has turned only slightly westward, The dew is heavier but not remarkably so. Patterns whisper from the margins, promising that careful witness is never wasted. He has not yet given the world an atomic theory, nor even formed the word atom on his careful tongue, yet the habit that will make such a theory possible is already fixed. Observe, record, compare, and trust the sum. Morning soon will seep across the sky. He feels it arriving, invisible as the turning of the earth, and allows a small thrill to pass through him. Another set of readings, another line in the ledger. One day he will stand in a bustling city, lecturing seasoned scholars on the weights of elements. One day he will sketch rings and circles on a chalkboard to represent particles no eye has ever seen. But every future lecture, every chalk mark begins here, in a silent cottage, with a boy's steady hand moving ink across the page while the world sleeps. He closes the diary for the second time, blows out the lamp, and sits motionless, listening to the last sigh of the flame. Outside, the first sparrow stirs in the hedge. Its faint chirrup marks the border between night and dawn, between the unknown and the slowly revealed. In that liminal hush, John Dalton offers a silent promise: to keep counting, to keep asking, to keep believing that beneath every breeze and raindrop lies a rhythm waiting to be named. The promise hangs in the dim room like a single glowing ember, small, warm, and destined to outlast the night. Threads of a Quaker childhood. Morning unfolds over Eaglesfield with the measured patience of a loom, each pale strand of sunlight sliding between cottage rafters as if woven there by unseen hands. In the Dalton household, weaving is more than livelihood. It is rhythm, creed, and silent tutor. John's father, Joseph Dalton, sits at the broad frame loom that occupies half the front room. The treadles thump, the shuttle sings across the warp, and the new day's fabric gathers on the beam in neat, practical rows. The scent of raw wool mingles with oatmeal porridge cooling on the hearthstone, a fragrance John will forever associate with industry and restraint. Quakers call their places of worship meeting houses, but the first meeting any child attends is held around the family table. Here plain speech is law, humility a constant guest, and work a kind of quiet prayer. When Joseph raises his eyes from the loom and asks his son how the wind blew at dawn, John answers in the tidy cadence of his ledger. Northwest, father, gentle but steady. No embellishment, no flourish. Facts alone, offered as truth's small tithe. Between weaving and instruction, Joseph has little time for elaborate schooling, yet he recognizes the sharp hunger in his second son's eyes. Books arrive in odd trickles. A borrowed arithmetic, a weather almanac left by a traveling friend, the tattered pages of a natural philosophy tract rescued from a market stall. Money is scarce, so John mends each spine with scraps of thread and beeswax, treating every volume as a seed that might someday split stone. He reads aloud to his sister Mary while their mother winds yarn. Sometimes Mary's small voice interrupts with a question: "Why does frost paint flowers on the window panes?" And John pauses, pencil poised, to note both query and provisional answer in a growing notebook titled Remarkable Phenomena to be Examined. He is not yet certain how frost forms or why patterns differ from pane to pane, but he scents a pattern beneath the beauty, and that is enough to keep the page open. Lessons extend beyond the cottage walls. On market days John walks beside the family cart 16 miles to Cockermouth, a sack of homespun on his shoulder. The road skirts upland peat bogs that exhale cool vapors even at noon, and he measures their chill by resting his palm first on moss, then on nearby stone. Returning at dusk, he sketches their arrangement from memory, adding observations on bog cotton and insect hum. The world offers itself as endless exercise. Each texture, each bird call, a fresh line awaiting entry. Quaker meeting on first day presents a different discipline. Silence. John sits on the plain wooden bench, feet barely brushing the floor, while adults bow their heads in still communion. Outwardly nothing changes. Inwardly, thoughts range vast and free. In that hush he gathers the week's questions like wool into skeins, teasing out knots of curiosity until the thread runs smooth. Occasionally a visiting friend speaks, exhorting the congregation to walk cheerfully over the earth, answering that of God in everyone. John interprets those words through the lens of inquiry. If there is divinity to be answered, surely its language is the order written into nature's face. At 15 he inherits the village school after the previous master departs for a mill town. The building is a single-room stone cottage with a damp floor and a stove that smokes in high wind, yet John accepts the post with solemn gratitude. By day he drills younger children in spelling and ciphering. By night he copies their arithmetic errors into a separate ledger, analyzing which numbers most commonly trip the unwary mind. The exercise teaches him that patterns reside not only in rain gauges and thermometers, but also in human frailty, a lesson he will revisit whenever critics dismiss his atomic speculations as too neat for the untidy real. Eaglesfield offers few instruments beyond slate and quills, so John fashions his own. With a length of catgut, a whittled dowel, and a carved wooden index, he constructs a rudimentary hygrometer, suspends it by the hearth, and notes the degree to which damp evenings stretch the gut. Later, comparing entries, he suspects that humidity rises predictably ahead of certain wind shifts. Confident patterns always beckon him onto new ground. The village smith, taking pity on so earnest a scholar, throws open his scrap pile. John selects thin glass tubes, melts them over the forge, and traps columns of air to serve as crude barometers. He learns to read the slight descent of trapped mercury before storms and announces expected rainfall to neighbors who soon rely on his predictions to save hay from sudden downpours. When their gratitude arrives in gifts of eggs or a loaf of oat bread, he records each favor beside the corresponding forecast. Cause linked to consequence, observation to outcome. Evenings he spends beside the hearth with Mother Deborah Greenup Dalton, spinning flax. Her wheel whirs softly. John's pen hovers above his diary. She tells him stories of her own childhood. Cattle driven across the high passes, winters so cold glass shattered in the windows. Each anecdote becomes data in disguise. Temperature extremes, livestock migration, survivable frost depths. He cannot help filtering tale into tally. By 16 he has filled 5 notebooks. Weather entries, botanical sketches, arithmetic puzzles for his pupils, and a slim volume titled Miscellanies in which he interrogates everything from the play of light on morning mist to the peculiar way the house lamp dims when air grows foul. Now and then he notices drawings of small circles, shaded or hollow, linked by lines. An embryonic symbolism born not of deliberate theory but of subconscious order seeking shape. Still, childhood is not all books and barometers. After lessons he plays fives against the chapel wall, his quick hands keeping pace with older boys. When he misjudges a bounce, he measures the error, wonders whether wind speed, or the ball's leather stiffness, might subtly alter trajectory. Early curiosity clings to him like burrs to woolen stockings. Nothing escapes its cling. One dusky afternoon, lightning sheets across the western sky, startling a flock of rooks into ragged flight. John feels the hairs on his forearm rise and races for open ground with a jar coated thinly in resin. He hopes to capture what Benjamin Franklin called electric fire. The storm passes before he returns, yet the impromptu dash leaves him soaked and exhilarated, convinced that nature's forces prefer bold company. Later that night, wrapped in blankets while thunder rolls away toward the Irish Sea, he summarizes the day with characteristic modesty. Observed electricity in atmosphere, attempt at capture inconclusive. Requires vessel with superior seal. Nothing more, nothing less. No boast, no regret, only the invitation to try again under improved conditions. In these small acts the spine of his future theory stiffens. Honest record-keeping, craftsmanship with makeshift tools, courage to chase storms with resin jars. Each thread winds into a fabric resilient enough to carry a revolutionary idea. He does not yet know that the paired virtues of simplicity and precision, Quaker hallmarks, will someday shape the way chemists everywhere depict matter itself. For now he sleeps beneath a patched quilt, lulled by the loom's nocturnal clicks as his father finishes the day's length. Beyond the cottage, fog slinks over the meadows, softening every edge. Within, another sort of mist clears, revealing an abiding principle. That truth, like cloth, is assembled from countless individual fibers, each measured, aligned, and tightly bound. John Dalton, adolescent spinner of data and dreams, turns on his side and drifts toward morning, unaware that the threads he gathers tonight will one day bind the entire scientific world to the quiet conviction that everything, leaf, cloud, heartbeat, and star, is fashioned from atoms. Kendal's quiet academy. Dawn again, but the scene has shifted. The boy who once traced frost flowers on cottage windows now strides the cobbled streets of Kendal, a market town whose gray-green slate roofs brood beneath the Cumbrian hills. He is just 15, tall, solemn, a little threadbare, and yet he carries the keys to a boarding school that will soon rely on his every decision. When he unlocks the wooden door each morning, the latch clicks with a confidence he does not yet feel but refuses to betray. The school occupies 2 rooms above a cooper's shop that smells of resin and oak. One chamber is sleeping quarters, the other a classroom sparsely furnished with benches, slates, and a single long table scarred by decades of penknife initials. Beside the hearth stands a blind man, John Goff, mathematician and natural philosopher, who teaches by ear and touch. To the pupils he is Mr. Goff. To Dalton he becomes mentor, sparring partner, and living proof that the mind's eye can illuminate more than the sharpest vision. Lessons begin at 6. Boys and a few bold girls recite Latin verbs in sing-song cadence, while dawn light leaks through diamond-paned windows. Dalton moves among them, ruler in hand, not for striking knuckles, but for guiding columns of figures into perfect alignment. He believes clarity of script breeds clarity of thought. When someone blots ink, he replaces the sheet and begins anew, explaining that error becomes permanent when we accept smudges as sufficient. They study arithmetic, geometry, and bookkeeping in the morning, reading, composition, and a touch of natural history after a midday bowl of broth. Dalton's voice never rises. Instead, he poses questions that feel like puzzles. If rain falls in equal drops yet fills one barrel faster than another, what else must be acting? A hush settles while pupils frown at their slates. Eventually a timid hand rises. A guess stumbles forth. Dalton nods, adjusts the premise, and sets them counting again, teaching by patient increments as a spinner feeds flax to the wheel. Evenings belong to the ledger once more. Behind closed shutters he and Goff compare records, temperature, barometric pressure, wind direction, copied from their separate instruments. Goff's fingers glide over raised marks on paper where Dalton has pricked holes to represent data points. Together they follow the embossed dotted line of a week's temperatures, murmuring correlations between sudden thaws and dips in pressure. The older man, blind since infancy, models an intimacy with abstraction that mesmerizes the younger. If sight is unnecessary for grasping patterns, perhaps matter itself need not be visible to be understood. Occasionally, thunder rumbles over the fells, shaking chalk dust from rafters. Pupils rush to windows. Dalton moves instead to his instruments, noting the precise instant the barometer falls. Later, he will pit those observations against Goff's collected wisdom on electricity and magnetism, finding in their debates the thrill of friendly contention. They argue but never quarrel. Each trusts facts more than pride. Money remains scarce. The school survives on modest fees and the Daltons' willingness to forego comfort. Supper is oatcake and cheese. Candles are trimmed to stubs before being replaced. Yet frugality sharpens invention. Dalton prepares his own ink from galls and iron filings, distills alcohol for thermometers using a tin kettle and a length of lead pipe, and devises a portable barometer from a sheep's bladder, glass tubing, and lamp oil. Pupils watch, astonished, as their teacher transforms common objects into windows on hidden laws. One winter evening a new curiosity intrudes. Returning from market, Dalton buys a bolt of bright scarlet cloth to mend the boy's worn breeches. Under the classroom lamp, the fabric appears muddy brown to him, though everyone else exclaims at its brilliance. He frowns, fetches ribbons in blue and green, and perceives no difference among them. The discovery unsettles him, not embarrassment but wonder. He quizzes pupils on their own perceptions, charts which colors confound which eyes, and writes a paper for the Manchester Literary and Philosophical Society, though he has never yet crossed its threshold. The paper will travel ahead of him, marking his path. Meanwhile, the academy grows. Reputation spreads through valleys and farms. Dalton's pupils calculate accounts without error, write prose that wastes no word, and recite botanical names alongside English ones. Enrollment rises. Benches multiply. The blind mathematician smiles to hear new voices reciting Euclid. Yet success does not dull Dalton's drive to classify. He measures chalk consumption, candle burn rates, even the volume of breath a pupil exhales after running the length of the corridor. Every datum enters a book, and every book earns its place on a narrow shelf beside his cot. By 19, he has weather records for over 1,000 consecutive days, each line penned before breakfast. He detects a pattern linking aurora sightings with sudden magnetic needle swings and speculates, quietly to Goff, that unseen subtle matter may pervade the sky. The older man cautions that speculation must follow evidence, not lead it. Dalton agrees, but a private conviction takes root. The world's vastness is governed by minuscule agents, and the surest way to sense them is through number. Sunday brings respite. After silent meeting, he leads willing pupils onto the fells, turning rambles into field studies. They collect lichens, count the vibrations of a grasshopper's wing beats, measure the angle of the sun at noon using walking sticks as gnomons. At a tarn's edge, he drops pebbles of different stones, timing their sink rate, and invites guesses as to why one disappears faster. Hands shoot up. Arguments blossom. The lake reflects clouds that drift like slow thoughts across the water. In moments like these, the academy expands far beyond its 2 rooms, bounded only by the horizon. Still, there are nights when loneliness presses. The responsibilities of master, tutor, caretaker, and scientist converge, and fatigue fogs his vision. He writes letters to his older brother Jonathan, who teaches alongside him, outlining improvements for the curriculum and confessing in closing lines doubts about his own pace. Jonathan replies briskly, "What thou hast set thyself, finish it." The admonition steadies him more than comfort could. So he rises again before dawn, trims the candle, and sketches circles linked by lines, symbols he invents to mark different gases trapped in his rubberized tubes: a filled circle for nitrogen, a hollow one for hydrogen, a ringed circle for oxygen. He does not yet know these sketches will seed a universal chemical language. He only knows the classroom stove smokes less when the damper is half shut, a small, observable truth that belongs beside the grandest theory. Years slide past. Pupils graduate, return as visitors, and marvel that the school's ledgers look thicker than its library. Dalton's hair darkens to near black, his shoulders broaden, but he still prefers the plain brown coat mandated by Quaker testimony. Fashion, like flourish, seems wasteful when there is so much left to record. One autumn, a merchant from Manchester visits with his son, seeking admission. He scans the cramped room, the shabby benches, the weather-stained ceiling, and raises an eyebrow. Dalton offers no apology, only the morning's barometer reading. The merchant asks why such a statistic matters. Dalton answers that commerce depends upon weather as surely as sails depend upon wind, then predicts rain within 36 hours based on falling pressure and southerly breeze. The prediction lands true. The merchant's respect follows. Soon, whispers of a larger opportunity drift across the Pennines. A new industrial city hungers for teachers who love numbers. The academy, once a daring experiment run by a teenager, has become his identity. Yet he feels the walls contract, hears a distant hum beyond them. Mills, laboratories, societies of learned men debating caloric, phlogiston, and new airs discovered by Priestley. The ledger urges him outward. More variables, finer instruments, wider scope. One cold December evening he walks the empty classroom, fingertips brushing bench tops worn smooth by years of restless scholarship. He thanks the silent planks and closes the door behind him, leaving chalk dust swirling like nebulae in lamplight. Students sleeping above hear his footsteps fade down the stair, unaware that in losing their master they are lending him to the world. Dalton heads toward Manchester with a crate of notebooks, a bundle of instruments padded in straw, and an unshakable faith that the same discipline which binds a classroom together might bind the universe to arithmetic. He will remember Kendal fondly, a crucible of patience, rigor, and blind mentorship, but he will not look back. Ahead, he senses gases waiting to be weighed, symbols waiting to be born, and a theory waiting to reveal itself atom by atom. Manchester's invisible engines. A rain-darkened coach rattles onto the smoke-streaked streets of Manchester, and John Dalton steps down into a world that hums like a giant loom. Brick mills rise on every side, their tall stacks exhaling clouds that blush orange in the furnace glow. Steam whistles pierce the dusk. Iron rails tremble under cartwheels. Yet beneath all this clamor lies a promise that draws him forward. Rooms enough for instruments, colleagues enough for questions, and time enough to chase the hidden architecture of air. He lodges first in a modest house on George Street, sleeping under a slanted roof that drums with soot-flecked rain. By day he teaches arithmetic and natural philosophy at the fledgling new college. By evening he climbs a narrow staircase to a laboratory lent by the Manchester Literary and Philosophical Society. The room smells of lamp oil, pine shavings, and the faintly sweet tang of coal gas seeping from unfinished pipes. Two sash windows look toward the Irwell River, whose sluggish current mirrors smokestacks like upside-down exclamation marks. He unpacks his crates, glass tubes stoppered with whittled cork, wooden barometers wrapped in sackcloth, a small bell jar chipped at the rim, and several leather bladders once meant for wine. These humble tools, nurtured in cottage and classroom, feel almost shy among the society's more polished apparatus. Polished brass air pumps, burnished balances, and a library whose spines gleam with gilt. Yet he sets his own devices on a scrubbed pine bench with quiet pride. They have served him longer than any city could. Even before he finishes arranging them, the ledger opens of its own accord, as if by habit. Manchester's air, he notes, hangs heavy with soot that dims the afternoon sun to a copper disk. Barometer, 29.84 inches. Thermometer, 56 degrees Fahrenheit. Wind, southwest, moderate. He adds an asterisk beside the soot remark. No more than a speck of ink, but already a germ of curiosity. Does this smoky blanket alter the weight of the air itself? Within weeks he is a fixture at society meetings. His plain Quaker coat a sober island amid bright waistcoats and silk cravats. He listens more than he speaks, head bowed, hands folded, until someone cites a measurement that jars his neatly kept ratios. Then he lifts his gaze, asks a single precise question, and lets silence do the rest. Listeners soon realize the young teacher carries whole ledgers of evidence behind each modest query. One chilly October morning he tests a rumor that marsh gas will burn with a blue flame. He journeys to a nearby bog at dawn, digs a trench, and traps the rising bubbles beneath an upturned flask. Back in the lab he nudges a taper toward the mouth of the flask and watches a pale flame bloom, ghostly, silent, undeniably true. He weighs the exhausted air afterward, comparing it to his records, and wonders why the burned residue presses the scale differently from fresh city air. Something invisible has fled, leaving its signature in mass alone. Soon shelves fill with labeled bladders. Common air, hydrogenous gas, fixed air from fermentation, nitrous air from heat of niter. He pads their corks with tallow, suspends them upside down in mercury troughs, and measures how each gas pushes upon the liquid column. Numbers march across fresh pages, pressures, volumes, temperatures, tidy armies forming patterns no single value can reveal. Night after night he leans over the ledger until tallow gutters and the room shivers in sudden dark. During daylight lectures he reenacts these tests for wide-eyed pupils. He lowers a candle into a tall glass jar filled with dephlogisticated air, and flames roar brighter. Lower it into fixed air, and flames die with a sigh. Each demonstration confirms that what we call air is no single substance but a parliament of gases, each with voice and vote. He dares to imagine those voices as particles, solid, weighty, yet too small for sight, whose motions explain every difference his scales detect. On a raw winter evening the breakthrough arrives, unannounced. He fills one bladder with mixed oxygen and nitrogen taken from city air and another with pure nitrogen. Both bladders appear identical, yet when he presses each under the same column of mercury, the mixed gas exerts a higher total pressure than the pure. He repeats the trials, swaps tubes, alters temperatures, and the result repeats like a refrain. Total pressure equals the sum of pressures each gas would exert alone. A simple truth, so clean it feels inevitable, nonetheless electrifies him. If gases behave as though they do not mingle but merely share space, might not each molecule fly independent, ignorant of its neighbor's identity? He writes the discovery in spare Quaker prose. The pressure of a mixture of elastic fluids is the sum of the pressures each would exert if it occupied the same space alone. There it is, Dalton's law of partial pressures, framed not as boast but as observation. Colleagues at the society murmur approval. Some raise cautious brows. But Peter Ewart, an engineer with a fondness for daring ideas, clasps Dalton's hand and declares the law a keystone ready for the arch. Encouraged, Dalton begins to weigh ambition against modesty. Never an easy contest. The result appears a few months later when he stands at the Society's lectern and, with a trace of tremor in voice, unveils a new chart. Symbols for elements rendered as circles, some solid, some hollow, some circled again. Hydrogen, a plain open circle. Oxygen, a dark disk. Nitrogen, a circle bearing a vertical line. Beneath them ratios, 1, 1, 1, 2, whole numbers everywhere. Watching seasoned chemists squint at these symbols, he senses another barrier giving way. If matter truly consists of indivisible atoms, chemistry can shed its cabinet of curiosities cloak and dress itself in arithmetic. Reactions will no longer be accidents but equations, and wait the royal road to meaning. He does not shout this vision. He simply holds up the chart until murmurs quiet, then invites the audience to verify each ratio for themselves. That night he walks home past spinning mills whose windows flare like lanterns above the river. The dull roar of looms reminds him that unseen motions, shuttles, gears, threads, combine into tangible cloth. In like manner, he muses, unseen atoms weave the whole material world, every substance a different pattern in the grand textile of creation. Soot falls softly on his coat. He brushes it away and smiles, considering that each speck may contain legions of carbon atoms locked by forces no man has yet named. In private moments, doubts flicker. What if atoms prove to be mere fancy, like the vortices once imagined to carry light? Yet the numbers refuse to bend. The law of partial pressures stands firm as Pennine granite. He recalls John Gough's gentle admonition, speculation must follow evidence, and finds relief in the ledger's impartial ink. When he closes the book, the data remain serene and persuasive. Letters begin to arrive from London, Paris, and Edinburgh. Some praise, some polite skepticism. Sir Humphrey Davy writes requesting clarification of Dalton's hydrogen value. Dalton replies with humility, enclosing fresh tables and inviting replication. He does not claim final authority. He offers a conversation shaped by figures. Even criticism feels like partnership when rooted in experiment. Amid these scholarly exchanges, life retains its plain textures. Each morning before lecture, he still ascends to the roof to record temperature and cloud cover. He still brews oats for breakfast, still mends his own coat cuffs. Walking to the society one crisp March dawn, he notices how chimney smoke billows higher on days when air is coldest and jots a margin note. Warm gas lighter, evidence of molecular motion? Another breadcrumb laid. City dwellers grow accustomed to the quiet man crossing town with a bundle of bladders slung like a peculiar musician's bagpipes. Children point, vendors laugh. He nods and steps on. Only once does he pause, at the Ancoats Canal, where icy water laps iron hulls. He imagines the hydrogen in his bladder buoying a balloon over such water, the partial pressure of each gas inside balancing the weight of cloth and rope. An airship of equations, ready to lift thought itself into broader sky. When evening settles, he returns to his garret, lights a lamp, and lays a fresh sheet on the desk. Tonight he intends no measurements, only a sentence meant for himself alone. If matter is composed of atoms, the path to understanding lies in their weight. The ink dries. He closes his eyes and hears the mill engines slowing, each piston coasting to rest. In the hush that follows, another engine, the mind's own, keeps turning, quiet but unstoppable. Beyond the window, a cold dark sky reveals brief tiers of starlight between smudges of smoke. Those distant points, he thinks, shine by laws that likely mirror the ones guiding his leather-bound gases. Invisible engines drive both star and steam, atom and atmosphere. Content. He bows his head, folds his hands, and lets the ledger sleep until dawn renews the invitation to observe, record, and trust what numbers say. Walks among the clouds. Mist softens the clang of morning mill bells as John Dalton folds his notebook and leaves the city behind for a rare holiday. A hired trap carries him north over moor and moss until stone factories yield to heather and larksong. When the reins are handed off at Keswick, he sets out on foot, barometer strapped like a pilgrim's staff, thermometer tucked in his coat. Each measured mile feels both familiar and strange. Familiar because these fells shaped his earliest questions, strange because every slope now whispers answers he never knew were hidden there. He climbs Cat Bells before dawn. Wind tugs at his hat, peat springs under boot heel, and Derwentwater glimmers far below like a pane of dark glass. At the summit he records pressure, temperature, direction of drift, then watches cloud shadows slide across patchwork fields. In his mind the figures begin to converse. Lower pressure aloft, cooler air, thinner density. They confirm at altitude what the city laboratory hinted, that invisible particles thin out as surely as footsteps grow shallow in thin air. Later he descends to a sheepfold and rests beside a tarn ringed with cotton grass. He schemes a tin dish across the water, noting how quickly ripples still. The hush reminds him of mercury settling in a tube, of gases taking their share of space without disturbing neighbors. A sudden thought sparks. The vapor above this tarn must exert its own modest push, independent of the heavier nitrogen and oxygen beneath. He jots a single line. Aqueous vapor bears partial pressure in proportion to its quantity, else the dish would boil at all times. The idea slots into place beside his earlier gas studies like a gear meeting its twin. Throughout the week he walks ridge to ridge, chasing weather fronts the way poets chase sunsets. Each dawn he compares dew on south-facing stones with that on north-facing. Each dusk he times the lift of valley fog once sunlight fades. The pattern clarifies. Temperature, humidity, and elevation choreograph a predictable ballet. He feels the exhilaration of fitting fresh tesserae into an emerging mosaic. Where once he tasted air merely as cool or warm, he now senses its hidden census of particles. Water, nitrogen, oxygen, perhaps trace gases yet unnamed. All neighbors, all obeying arithmetic. Back in Manchester the notebooks thicken. Between lectures he plots vapor pressure against temperature, finding lines so straight they look ruled. He discovers that when two vapors share a vessel, each behaves as though alone, adding nothing but its own simple thrust. The law of partial pressures grows richer, subtler. Not just a quirk of oxygen and nitrogen, but a universal principle linking summer haze above a lake to flame inside a furnace. The same quiet handshake, each atom minding its private business, explains both. One gray evening, as soot drifts like ash from unseen fires, he copies the Lake District figures into a ledger marked Meteorologica Perpetua. The very act feels sacramental. Outside, factory whistles fade. Inside, a single conclusion brightens the page. Order lies hidden in every breath of wind, waiting only for numbers to coax it into view. He places his pen in the inkwell, closes the book, and rests a palm upon its cover. Under that modest cardboard, thousands of dawns and dusks now hum with coherence, murmuring the same truth. The sky, like the laboratory flask, keeps scrupulous account of its invisible tenants. Wooden spheres and whole numbers. Winter tightens its grip on Manchester. Frost feathers factory windows. Steam coils above canal water thick as pewter. In the society laboratory, a small coal stove casts an amber circle that catches John Dalton bent over a carpenter's tray of turned wooden balls. They range in size from cherry to plum, each sanded smooth, each tinted with oil and lampblack. On the bench beside them lies a scale sensitive enough to tremble at a feather's fall. He weighs the largest ball, labels it oxygen, sets its mass by fiat at 7 units. A smaller, lighter sphere earns the mark hydrogen, and a value of 1. Soon he has a cabinet of elemental proxies, each sphere's diameter whispering its relative weight. Why 7 for oxygen? Because the simplest ratios drawn from experiment point that way, and arithmetic beauty rarely lies. He begins arranging the spheres in tiny pyramids, 2 hydrogens kissing 1 oxygen, 3 hydrogens balancing 1 nitrogen, watching how snugly the pieces nest. The fit pleases him like well-planed dovetail joints in a Quaker meeting bench. These models follow him into lecture halls. Students lean forward as he rolls spheres across the desk, asking them to imagine forces they cannot see binding pieces they can. He couples hydrogen and oxygen, strikes flint above them, and a blue flame leaps, visible proof of an invisible union. Chalk follows on slate. Plus, symbols that look like children's puzzles yet carry the weight of worlds. In April 1803, he presents a formal paper titled Experimental Essays on the Constitution of Mixed Gases. The reading room fills with merchants, surgeons, engineers, curious to hear why this mild-voiced tutor insists on counting the uncountable. He speaks without ornament. Equal volumes of different gases hold equal numbers of ultimate particles. Atoms of each element bear distinct, immutable weights. Compounds form when atoms combine in the simplest whole number ratios. No thunder, only quiet statements sliding into place like well-made cogs. Questions follow, civil, probing but tinged with skepticism. If atoms exist, why does no lens reveal them? He answers that eclipses were predicted centuries before telescopes measured the solar disk. Gravity acted long before Cavendish weighed the Earth. Evidence precedes vision. Arithmetic precedes glass. He invites each listener to repeat his weightings, to test the numbers in their own fires and retorts. The audience disperses subdued, thoughtful, as though hearing distant machinery they cannot yet locate. Over the next months he compiles tables. Hydrogen 1, nitrogen 5, oxygen 7, carbon 6. Some values will one day prove off by simple multiples, but the scaffold stands. Chemistry, long a catalogue of colored precipitates and odorous gases, acquires a backbone of integers. Even skeptics concede the practicality of his symbols. Circles simple enough for any ledger, ratios easy to memorize. The wooden balls, once toys of demonstration, morph into icons of a revolution no cannon will announce. Recognition creeps rather than strides. Davy writes again, praising the simplicity of the sphere models. Thomas Young requests permission to reproduce the tables in the Philosophical Transactions. Each letter lights a modest spark of satisfaction, yet Dalton keeps routine undisturbed. Rise at 6, note the barometer, teach equations, return to the lab, weigh and reweigh gases until midnight tips in. One lamplit night, fatigue blurs the ledger lines. He leans back and lets eyes wander to the rafters, imagining each beam composed of invisible ranks of atoms, every pitch-pine fiber a staggered mosaic. The thought feels neither grand nor strange. It feels inevitable, as natural as breathing. He realizes then that the theory no longer belongs to him alone. Once arithmetic wears inevitability like a garment, ownership slips away. The stove pops. He stands, gathers the wooden spheres into their tray, and closes the lid. Each ball clicks softly against its neighbor, a mute reminder that wholeness rules the smallest domain. Outside, frost etches branches with lace so delicate it seems spun from numbers rather than ice. He watches his breath plume, the living proof of water molecules escaping warmth in perfect, measurable flights. Tomorrow he will begin drafting the first volume of a new system of chemical philosophy, setting down in austere paragraphs the doctrine that matter is granular, weights are destiny, and combination obeys the tally of integers. But tonight he allows himself one quiet indulgence. He opens the window a hand's breadth and listens to the city sleep. Looms pause, forges cool, yet a subtler industry continues. Atoms colliding, separating, reconvening according to laws newly spoken aloud. He whispers a single sentence into the cold. So the world endures, number within number. Then he latches the pane, banks the stove, and lets the spheres rest, sure that when dawn comes they will still keep silent company, each guarding its secret mass, each waiting to show the next seeker how simple the invisible can be. Patterns in pressure, proof in proportion. The clatter of Manchester fades as John Dalton buries himself in a disciplined ritual of weighing, heating, cooling, and noting. 1804 slips into 1805, and the city's mills adopt gaslit night shifts, but his true illumination comes from the steady hiss of experimental fires. He has grown restless with qualitative talk of airs. What exactly binds one gas to another in fixed measure? To find out, he collects a regiment of stoppered glass bulbs, each precisely 1 cubic inch. He fills a first bulb with nitrous oxide, a second with nitric oxide, a third with nitrogen gas alone. Side by side on a walnut shelf they look identical, yet every scale reading whispers a different mass. Those whispering numbers, copied into a ruled ledger, reveal at a glance that the compound gases outweigh the simple one by clean multiples. Twice, thrice, never by fractured fractions. Late winter storms rattle laboratory windows while he dissolves the figures into prose. If two elements unite in several proportions, the masses of one element that combine with a fixed mass of the other are simple whole number multiples. There, 9 unadorned words that compress weeks of midnight vigil into a rule later christened the law of multiple proportions. He tests it against carbon oxides, sulfur oxides, water and hydrogen peroxide, and each time the arithmetic holds like a well-cut dovetail. Whole numbers march across the page with a confidence that feels less discovered than remembered. He writes to William Henry, the physician-chemist whose friendship has matured through shared evenings of tea and cautious speculation. Henry replies from his surgery with cautious delight. Thy observations bear a harmony surpassing chance. Pray publish. Yet publication still unnerves Dalton. He prefers the solitude of verification to the glare of debate. It is Humphrey Davy, flamboyant, silver-tongued, already famous for taming nitrous oxide, who finally cajoles him into wider audience. When Davy tours the smoky literary and philosophical society rooms, he lingers over Dalton's forest of mercury-sealed tubes, then pronounces them the seedbed of chemistry's next harvest. Flattery is not Dalton's nourishment, but Davy's enthusiasm supplies the push he needs. Thus in 1808, printer's galleys flow through his hands like ribbons of potential misprint. A new system of chemical philosophy. Volume I emerges clothed in plain calf leather, but its contents stride far past the modest binding. Page after page pairs tidy circles, solid for oxygen, open for hydrogen, with uncompromising integers. Reviewers skim the early chapters on heat and expansion with polite nods, but they stop short when tables of atomic weights fill an entire folio sheet. Carbon equals 6, oxygen equals 7, nitrogen equals 5, hydrogen equals 1. Some readers, like Thomas Thomson of Glasgow, applaud the courage. Others, like Guy Lussac in Paris, mutter that a scale alone cannot measure the invisible. Dalton counters by returning to his bench. If the theory be true, new numbers will defend it. He builds a taller pneumatic trough, deeper and broader, fed by a hand pump scavenged from a textile factory. Into this glass vat he empties pre-measured charges of hydrogen and oxygen, ignites them with a fine platinum wire, and traps the resulting steam. When the vapor cools and condenses upon the walls, its mass tallies to the last grain with a theoretical ratio 2:1. The ledger ink glistens. His conviction hardens. He repeats the trial in front of skeptical colleagues, handing them the scales, inviting them to subtract tare weights for themselves. Every repetition chisels doubt into respect. Yet opposition persists. William Wollaston, a chemist of surgical precision, objects that Dalton's atomic weights misjudge oxygen by a whole number factor. John's Jacob Berzelius, writing from Stockholm, applauds the method but publishes amended tables in which oxygen is reassigned the convenient value of 8. Dalton, in print, admits that his own values may require doubling or having as finer balances appear, yet insists the principle is untouched. Atoms exist, and their unions write arithmetic into matter. Whole numbers, he maintains, care little which unit the chemist chooses for one element so long as every element abides by that same ledger line. Through each debate he remains the craftsman teacher. New college students arrive before sunrise to find their tutor already bent over copper retorts glowing cherry red. He hands them tongs, directs them to weigh calxes before and after reduction, and tasks them with repeating his partial pressure experiments until they can predict which gas will oust which from water inverting jars. Mistakes earn not scorn but questions. Every erroneous ratio becomes another rung toward understanding. In the evenings, dusty cloaked apprentices from nearby mills squeeze onto benches to watch the plain Quaker draw circles on slate as calmly as a clerk inscribes ledgers. They leave with sheets of integer rules pinned inside their hats like talismans. Some will carry those talismans to Paris, Berlin, Philadelphia. Dalton's personal life remains one of consistency bordering on ritual. Breakfast, porridge, milk, and a spoon of honey. Noon meal, bread and weak tea. Supper, cheese and an apple. Color blindness, once merely curiosity, acquires new poignancy when he purchases a lavish crimson waistcoat for lecture season only to learn from Henry that the garment is actually a mottled green. Rather than embarrassment, he records the incident, adding a footnote to his published paper on ocular spectra. Even his own retina, he jokes to friends, keeps private ratios of absorbed and reflected rays, and ratios deserve cataloging wherever they appear. One February night in 1810, he lays a transparent glass square across a window ledge and breathes upon it deliberately. Fog blooms, water beads, and gravity knits droplets into a descending pattern. He times the coalescence of each drop and sketches their growth under a watchmaker's loupe. Those sketches stand testament that the same atomic simplicity rules liquid condensation as surely as gas expansion. His convictions now reach beyond chemistry. If atoms underpin water and air, Surely they underlie rocks and living tissue, perhaps even the fiery glow of stars glimpsed between Manchester smogs. But speculation must not outrun evidence. He shelved that wonder, content for now to describe the earthbound part of the pattern. By midsummer, he is fielding invitations to demonstrate his sphere models at the Royal Institution in London. The prospect unnerves him. He dislikes travel, dislikes crowds, but the ledger nudges him outward. Standing on the mail coach as it rolls past hedgerows, he fingers a small wooden oxygen sphere in his pocket like a rosary bead. Each rotation steadies his mind. Count, compare, combine, separate. 4 silent verbs that have shepherded him from Cumbrian mist to the threshold of global debate. The lecture hall proves hotter than his laboratory, smelling faintly of whale oil lamps and curious humanity. He arranges his spheres on a velvet cloth, lifts 2 hydrogens and 1 oxygen before the assemblage, and speaks plainly. Here is water upon its invisible foundation. Some in the audience nod, some arch eyebrows, yet all feel the gravity of integers. Afterward in the corridor, a young Michael Faraday, then a bookbinder's apprentice, catches a glimpse of the tableau and feels, as he would later record, a hush as though traffic on the Strand had ceased. Dalton, gathering his kit, is unaware of planting seeds that will one day blossom in electromagnetic fields. When he returns north, the mills along the Irwell seem louder, the smoke thicker, but the invisible world within that smoke feels newly lucid. He dutifully writes letters thanking Davy, Wollaston, Berzelius, even the stern critics who pry at numerical quirks. In each note lies the same unshakable refrain: whatever refinements the future may impose, atoms will remain the counters with which nature tallies reaction and repose. As autumn fog curls along canal towpaths, Manchester shopkeepers light early lamps, and Dalton, quill scratching, closes his latest weather entry. Pressure, temperature, humidity. The triad repeats: measurable, verifiable, unfazed by disbelief. He sets the ledger aside, dampens the stove, and allows himself a smile. The arithmetic of atoms, once a private hunch, now strides the public square, aided only by modest observation and the stubborn clarity of whole numbers. Honors, humility, and the slow eclipse. Honor arrives on a gust of coal smoke and trumpet fanfare in the spring of 1814, when the Royal Society elects John Dalton a Fellow without the customary entrance fee. The parchment, sealed with red wax, feels absurdly ornate in hands accustomed to rough-fibered notebook paper. He shows the document to William Henry, who claps him on the shoulder. He shows it to Quaker friends, who merely nod, reminding him that no outward badge alters inward measure. On the appointed June morning he dons a new broad-brim hat, hires a barber to tame his unruly curls, and boards the London coach once more. The induction ceremony proves shorter than the journey. Sir Joseph Banks, white-haired guardian of the society, offers a cordial greeting. Dalton signs the charter book with spare precision, and within minutes finds himself at a crowded soiree where crystal decanters catch candlelight in rainbow arcs he cannot perceive. He listens to conversations swirl around geodesic domes, naval chronometers, and volcanic ash, posing questions only when his ledgered mind senses a lax figure. People notice the plain man's habit of dropping gentle correctives. "Excuse me, friend, but my own barometer yesterday read lower by 2/10, and quickly learn that understatement often proceeds from formidable certainty. Not all encounters are cordial. William Hyde Wollaston presses him on atomic weights, arguing that oxygen's rightful value is 8, not 7. Dalton, cheeks flushing, defends his choice. Any base number suffices provided ratios remain whole. The debate continues into small hours, leaving the gathering murmuring about Quaker stubbornness. Yet within months the two men exchange civil letters, each conceding that experiments, not tempers, will decide. Dalton privately records, "Contention tempered by courtesy may yet refine truth." London's bustle dazzles but exhausts him. He finds relief in Greenwich Park, where he times the fall of chestnuts to estimate terminal velocity through humid air. Such data might one day adjust his vapor pressure tables. Until then, the practice itself nourishes him. By August he is home in Manchester, arms full of donated instruments. A more sensitive balance, a small glass resonator for acoustic studies, a new electrolysis apparatus from Davy. The city's familiar grime feels almost welcome, its predictable soot another constant to be weighed and recorded. 5 years drift by, marked by lectures, incremental corrections, and the slow writing of a new system Volume 2. The second volume takes longer. He insists on verifying every value thrice, sometimes 4 times, because he knows critics now weigh each integer as heavily as lead. Meanwhile, young chemists across Europe adopt the atomic idea. In Stockholm, Berzelius refines the weight table with laboratory scale and relentless zeal. In Paris, Guy Lussac and Thenard integrate atoms into their monumental recherches physico-chimiques. Dalton watches their progress with a blend of satisfaction and caution. Theories, like children, sometimes outrun their parents' measured stride. 1817 brings unexpected laurel. The Royal Medal for pioneering research on gas absorption and atomic theory. The medallion, heavy and warm from its velvet case, feels oddly foreign. He thanks the society, then places the medal atop a shelf beside a cracked bell jar memorialized for its countless small explosions. The bell jar, he remarks to visiting students, has seen more truth than any ornament. His teaching load lightens as assistants. Many former pupils step forward. Yet he continues daily ascent to the observatory roof where a small cup anemometer clacks in the wind. By now the weather journals surpass 2 million words, enough to map 3 decades of Britain's capricious skies. A pattern emerges. When barometric pressure drops sharply and dew point converges, storm fronts invariably roll in from the Irish Sea. He drafts a paper proposing predictive charts that might aid mariners, but never submits it, fearing distraction from the more urgent chemistry manuscript. Age creeps in stealthily. By 1822 the neat script in his diaries wavers. The left margin occasionally tilts. Friends notice a slight drag in his right foot. One bleak January morning he suffers a mild stroke while lighting the laboratory stove. Recovery is slow but thorough. He resumes weighing calcium carbonate within a month, but the brush with mortality kindles a fresh urgency. He arranges his notebooks by topic, labels glass slides containing colored glass experiments on vision, and revises his will to leave the entire trove to the Manchester Society. Knowledge, he believes, must never depend on a single heartbeat. Public acclaim escalates even as physical vigor wanes. In 1830 Oxford grants him an honorary Doctor of Laws. Newspapers hail him as the Newton of Chemistry, a title that makes him wince. On receiving the doctorate robe, he wonders aloud whether the cloth's crimson hue is, in truth, the muddy shade his eyes report. The jest sets Don's chuckling, yet reminded of his color-blind paper, several pledged donations toward optics research. Thus an idiosyncrasy once met with teasing now sponsors new science, a symmetry he quietly cherishes. The second, more severe stroke comes in 1833. For days his right side lies numb, speech slurs, figures blur. Nurses fear the worst, but discipline forged in cold Cumbrian dawns refuses surrender. He relearns pen grip by tracing simple circles, one empty for hydrogen, one shaded for oxygen, again and again until the lines tighten. Visitors later remark that Dalton recovered his handwriting by rehearsing the very atoms he had given the world. July 26, 1844. The ledger entry of that date stops midline. Barometer 29.92. Sky fair, wind east-northeast. Sometime soon after, sitting upright at his work table, John Dalton's heart fails. The pen slips. Ink blooms against the page like a final, silent exhalation. Manchester responds with unprecedented homage. More than 40,000 mourners file past his coffin, the lid removed at his own request so that friends might see there is no mystery in the last change. Quaker plainness grants no marble effigy, but school children line the streets holding small wooden balls strung on twine, a teacher's lesson transformed into civic rite. In the months that follow, Royal Society fellows debate whether to inter him at Westminster Abbey. His executors choose simpler ground, Ardwick Cemetery, among tradesmen and weavers whose toil, like atoms, sustains grand designs unseen. They place his weather notebooks in the Society archive, where they still whisper patterns to patient scholars. The wooden spheres find homes in classrooms from Kendal to Philadelphia, each nick and scuff a silent credential. Scientists refine his numbers, have some, double others, yet the integers survive every correction like bedrock. Today students memorize Avogadro's constant, Balmer's series, Planck's quantum, but the integer scaffold beneath their textbooks traces back to the quiet man from Eaglesfield. Whole numbers remain chemistry's heartbeat. Carbon 12, nitrogen 14, oxygen 16. None surprise us. We recite them as casually as calendar dates, seldom pausing to imagine the winter mornings and soot-choked laboratories that first coaxed those integers from invisible realms. Yet pause we should, for within each unremarkable integer lies the echo of pen strokes moving before sunrise, of leather bladders swelling with unseen gases, of courage that trusted arithmetic over eyesight, reputation, and even color itself. So ends the story told in daylight. But in the hush of midnight, when starlight filters through chimney haze, one might still sense a secondary narrative continuing unseen. Atoms combining, separating, and combining again in unbroken obedience to ratios first mapped by a Quaker schoolmaster. The machinery of the world hums on, invisible engines turning under every stone and every heartbeat. And whenever we balance an equation, weigh a reagent, or breathe a measured breath, we keep silent company with John Dalton, whose plain words gave the invisible its first permanent address in human thought. Ripples through the scientific world. The year is 1811, and a reserved Piedmontese lawyer named Amadeo Avogadro pores over Dalton's tables with a furrowed brow. He respects the neat integer ratios yet cannot reconcile them with Gay-Lussac's demonstration that 2 volumes of hydrogen unite with 1 of oxygen to yield 2 of water vapor. The numbers fit, but the volumes puzzle. Avogadro's answer hovers in a margin note written almost as softly as Dalton's. Equal volumes of gases, measured at the same temperature and pressure, must contain equal numbers of ultimate particles. 2 hydrogen particles and 1 oxygen particle, therefore, must expand into 2 molecules of water vapor, each harboring half-sized atoms within. The idea sails across Europe like a paper boat launched in a storm. Some chemists cheer, many shrug. Dalton himself, shown a translation of the 1811 memoir, shakes his head. He trusts weight, not volume, and the notion of compound molecules inside a gas seems to him an unnecessary embroidery. Still, the paper lies on his desk beside the wooden spheres, and now and then he runs a thumb along its edge, as if sensing a faint but persistent tremor beneath his own architecture of integers. While Dalton weighs and rewrites, others pick up Avogadro's thread. In Paris, Joseph Louis Gay-Lussac refines volumetric analyses with etched glass tubes so narrow that capillary forces must be coaxed with a candle flame. In Stockholm, Jöns Jacob Berzelius amasses a library of atomic weights vast enough to swamp a mule cart, correcting oxygen to 8 parts, sulfur to 16, copper to 63.5. He writes to Dalton, politely insisting that the Quaker's 7 for oxygen must yield to the elegance of 16 as soon as more exact balances appear. Dalton replies that elegance means less than fidelity to experiment, and the correspondence cools. Yet even he senses the ground shifting. When integer simplicity and empirical revision collide, simplicity sometimes limps away. Electromagnetism enters the arena next, riding on Michael Faraday's wire coils and revolving discs. Faraday's notebooks, penned in the same society rooms where Dalton once taught, speak of lines of force and indivisible charges that cling to atoms like invisible garments. Charges, masses, volumes. 3 separate currencies gradually converge toward a single treasury of hidden parts. Dalton, now in his late 50s, listens to these expanding debates from the fringes, a little deaf, still precise. He keeps adding weather entries. By 1820 they fill 41 ledgers, and still weighs gases whenever the mills gift him a quiet afternoon. Yet he will not budge from the conviction that atoms are solid spheres rather than Avogadro's duplex arrangements. His steadfastness, equal parts courage and caution, leaves younger chemists torn between reverence and restlessness. They honor the pioneer yet crave a map that reconciles weight with volume, reaction with vapor density. The reconciliation will not arrive until after his death, but its steps accumulate like railway sleepers. In 1827 Robert Brown peers through a microscope at pollen grains jittering on a water surface and wonders whether invisible particles might buffet them from every side. In 1840 Louis Thenard coins the term molecule for a cluster of atoms bonded yet free to float. In 1848 Kelvin calculates that a cubic inch of air must house more than a quintillion such clusters. The numbers soar beyond Dalton's original audacity, yet each new exponent traces its lineage to his wooden spheres. Across the Atlantic, the Massachusetts Institute of Technology prints student lab manuals urging novices to tabulate reactants by their atomic weights, following Dalton's principle of least whole numbers. In Heidelberg, a young August Kekule nods off in front of those same tables and dreams of carbon atoms dancing hand in hand to form a ring, benzene's invisible hexagon. Without integers, the dream might have evaporated. By 1858, Stanislao Conitsaro deploys Avogadro's long-ignored molecule concept to rescue the chaos of conflicting weight tables. He mails a pamphlet, Sunto di un corso di filosofia chimica, to every delegate invited to the Karlsruhe Congress of 1860. There, in a hall buzzing like Dalton's old laboratory furnace, Conitsaro's impassioned plea finally convinces a critical mass of chemists. Accept Avogadro's equal volumes principle, have or double the troubling atomic weights, and order will bloom. Mendeleev attends, notebook in hand, jotting margins thick with sketches that will ripen into the periodic table. Dalton is 16 years dead, but someone pins a small wooden sphere to the lecture podium as a talisman. Delegates smile, they understand. The integer scaffold has survived every correction. Oxygen may be 16, carbon 12, but the arithmetic of atoms endures. The keystone stands unfractured, even as the arch rises taller than its architect imagined. Back in England, the Manchester Literary and Philosophical Society celebrates the Karlsruhe triumph by exhibiting Dalton's weather journals in glass cases. Visitors marvel at neat columns of figures, the ink still dark as if written yesterday. School children trace fingers down barometer entries, whispering the names of storms long past. They do not know Avogadro's hypothesis by heart, but they feel the pulse of perseverance in every line. Thus the ripples widen. Atomic theory slips into geology, estimating Earth's age from lead and zircon, into medicine, where anesthetists calculate nitrous oxide doses by partial pressure, into the young science of thermodynamics, where Maxwell and Boltzmann weigh probability instead of gas in their balances. Dalton's initial caution about unseen entities gives way to physicists who happily imagine whole zoos of them, electrons, positrons, quanta, yet they still cite his demand for integers whenever measurement meets imagination. As the 19th century closes, Jean Perrin counts Avogadro's number by watching tiny emulsion droplets drift in a gravitational field. Photographs of the drift points, black dots on white cards, look eerily like Dalton's chalk circles. When Perrin presents his results to the French Academy in 1908, he dedicates the lecture to John Dalton, whose simple faith in numbers made these measurements conceivable. The dedication travels home to Manchester on a Paris mail packet. Librarians place a clipping beside the cracked bell jar, and the bell jar's silence feels suddenly eloquent, one century of experiments sealed inside glass, another dawning under flickering electric lamplight. The ripples keep spreading, wave after wave, though the first stone was thrown by a Quaker boy timing dewfall beneath a Cumbrian moon. Lanterns in the dark. Night settles over the modern city like velvet dust. Traffic signals wink emerald and ruby where gas lamps once hissed. Inside a quiet study, you listener, lean back in the half-light, and the invisible engines Dalton named continue their tireless work. Oxygen and carbon dioxide change partners in your breath. Salts migrate across nerve endings. Photons, chopped into quanta, tap at your eyelids. Imagine each process as a tiny lantern, glowing then dimming, guided by ratios so precise they might have slipped from Dalton's very pen. High above, satellites track atmospheric pressure fronts using sensors calibrated in parts per million. Their data descend into computers that still quote Dalton's partial pressure law when predicting whether tomorrow's sky will shine or storm. A meteorologist in Tokyo and a rover trudging across the Martian regolith both rely on that same law, transmitted across centuries and millions of kilometers with no loss of decimal fidelity. Move closer. In a hospital theater, an anesthetist adjusts a mixture of isoflurane and oxygen, trusting that each gas exerts its own measure of push inside the breathing circuit, exactly as Dalton demonstrated with leather bladders and a mercury trough. Pulse oximeter blinks a steady green. Somewhere else, a craftsman hardens steel by tuning the carbon content to fractions first standardized on Berzelius's amended carbon weight, descendant of Dalton's 6. Even in the hush of a library, readers handling brittle 19th-century volumes breathe out moisture that condenses on cold window panes. Each droplet forms when water molecules, carrying their own small pressure, overwhelm the air's capacity to keep them apart. They purl, slide, and merge, tracing lines that echo the graphs Dalton drew after dawn walks in the fells. Consider, too, the lights of theory that still flicker. Quantum chemists sketch orbitals, teardrop clouds of probability instead of billiard ball spheres. Yet the integer heart beats on. Electrons come in whole counts, protons in whole counts, the Pauli exclusion principle merely a sophisticated guard ensuring the tally never fractures. When students write H2O, they embed Dalton's prime directive inside each subscript. Now picture the ledger he closed nearly 2 centuries ago. Imagine lifting the cardboard cover and sensing the crisp rustle of pages thick with dew points and cloud heights, storm tracks and aurora sightings. Each number lies exactly where he placed it. None has faded into myth. Scholars digitize the pages, feed them into climate models, and discover subtle insights about long-term weather cycles over the Irish Sea. Dalton's dawn vigils thus illuminate forecasts spread across phone screens worldwide, lanterns guiding ships he never dreamt of. The ripple reaches even into art. A composer, reading of color blindness, pens a string quartet where the viola line remains steadfast on one pitch while violins modulate around it. Musical homage to Dalton's steadfast integers surrounded by a swirl of evolving theory. In a gallery, a painter dots a canvas with layered circles, solid, hollow, ringed, each daub a chromatic nod to the original sphere symbols. Visitors admire the pattern, unaware that they are strolling through a molecular hymn. Step back once more, far beyond Earth. Astronomers measure exoplanet atmospheres by parsing starlight filtered through alien clouds. Partial pressures of sodium vapor, water, methane, all extracted by ratio, tell whether oceans lap beneath those distant hazes. The technique, so new it was science fiction in Dalton's era, still recites his arithmetic. Even where air is warmer than molten lead, the integers hold. Finally, return to your own breath, the slow inhalation, the softer exhalation. Within each lungful, hundreds of septillions of nitrogen atoms glide past oxygen atoms in perfect indifference, sharing space without sharing identity. Their collective push matches exactly the sum of their individual impulses, no more, no less, just as a quiet man in a sooty garret proved with mercury, patience, and faith. Let that image dim the room around you. Imagine the city lights outside fading one by one until only a vault of stars remains, each star a furnace counting atoms by the trillions, turning hydrogen into helium with mathematical certainty. Picture Dalton walking beneath such a sky, clutching his homemade barometer, sensing without yet knowing the fusion catalogues overhead. Feel how small he was, how immense the canvas, yet how certain that law ruled both. In that vast silence, let the integers pulse like distant beacons. 1, 2, 3, steady as footfalls on a country lane. They lead you from chatter toward stillness, from scattered thought toward the single simple notion that everything, breath, heartbeat, starlight, is stitched together out of units whose dance never misses a beat. Trust that rhythm. Allow it to cradle your awareness, as if each steady count were a lantern placed along a dark path. Each step grows softer, slower, until numbers themselves slip into a hush too gentle to measure. Rest there, in the company of silent atoms, while the story prepares its final bow. Legacy and sleep descent. The story has carried us from dew-bright fells to soot-veiled mills, from a boy's frost-bitten notebook to charts that bend starlight into arithmetic. Now the final chapter unfolds in a quiet room, where every ticking second slows as if reluctant to disturb the hush. A single window faces east, its glass still dark, for dawn has not yet troubled the horizon. In the half-light a plain wooden desk stands sentinel, its surface polished by decades of careful elbows and ink-stained cuffs. At the desk's center lies John Dalton's last ledger, bound in calfskin darkened by age, corners gently rounded by daily use. The cover rests loosely closed, one torn ribbon marker peeking between pages like the tongue of an unread secret. A slender quill, its tip splayed from long service, sleeps beside an empty inkwell. The scene invites stillness, yet even in stillness, legacy breathes. Imagine the ledger's pages the way Dalton would have felt them, thick, lightly textured, holding ink without bleeding. Each line is ruled with the steady patience of an artisan who understood that order can soothe an anxious mind. Lift the cover in your thoughts. Feel its slight resistance, then the soft sigh of paper releasing stored air. Columns of figures appear, running straight as violin strings. Barometer heights, thermometer readings, dew point differences, ratios of gases weighed and reweighed. The handwriting, firm at first, then wobbling gently in later years, forms a slow-motion portrait of a lifetime's discipline. Every numeral is deliberate, never rushed, never casual, as though the ink itself respected the gravity of being set beside an integer that might guide ships at sea or syringes in a ward. Turn a page. Here is a storm traced hour by hour across the Irish Sea. Pressure tumbling, wind veering, rain drumming roof tiles in Manchester long before lightning reached them. Another page records a summer drought so stark that the Irwell shrank to a trickle between algal stones. Dalton noted how vapor seemed to vanish before sunrise, how bricks in the mill chimneys cracked from heat. Still farther along lie tables of atomic weights. Hydrogen 1, oxygen 7, nitrogen 5, carbon 6. Some of those numbers have since been doubled, others halved. Yet their relational music remains impeccable. The ratio, not the absolute, carried the revelation, and the ratio stands. Hold that truth a moment. Perfection of relationship outlasts imperfection of detail. Close the ledger gently. Feel its weight dwell in your palms. It is not heavy, yet it contains centuries, because future eras found in those columns a tuning fork for their own inquiries. A physician in Boston measures gas mixtures during ether anesthesia. A meteorologist in Nairobi calculates partial pressures before a monsoon. A chemical engineer in Seoul designs catalytic converters that coax nitrogen and oxygen into cleaner companionship. None of them meet Dalton's gaze, yet each one holds a tiny lamp first lit by his integer creed. That lamp, passed from lab to classroom to orbiting satellite, never once dims for want of oil. Numbers fuel it infinitely. Shift your attention from ledger to room. Shelves line the walls, cradling modest relics. A cracked bell jar with a scalloped rim, a sheep's bladder tanned and brittle, once bulging with mixed gases, a carpenter's box of wooden spheres, their paint rubbed thin where countless fingertips rolled them across benches. On the lowest shelf stands the portable barometer Dalton lugged up Cumbrian slopes, brass frame dulled, mercury column frozen in silence. He carried it before dawn, when skylarks still dreamed, to measure the hush between mountain and mist. Even now the instrument seems poised to whisper its reading if only someone would tilt it to the light. Beside the shelves a narrow cot rests against plaster mottled by decades of stove smoke. The woolen blanket is patched, the pillow flattened into an honest biography of nights spent scribbling until fatigue closed the day's last parenthesis. On the floor lies a small carpet, edges frayed, colored a dim shade Dalton might have misread. He would not have cared. Function eclipsed flourish in every corner of his life. Yet the aesthetic the room exudes is not poverty. It is clarity. Nothing distracts from thought. Nothing rivals the solemn glow of a truth arriving unannounced at midnight. Let your imagination settle into the cot, feeling the coarse blanket against your back, hearing the distant city, today's city, hum through glass panes. Buses hiss, neon buzzes, a late ambulance wails, yet those sounds fade quickly, muffled by thick brick that once soaked up loom vibrations. Inside, the air is cool and steady, unmoved by drafts. It bears its own bouquet. Faint ink, old leather, a memory of coal lingering in wood grain. Breathe it in quietly. Know that the molecules brushing your lungs obey the very law this room gave the world. Each gas contributes its share of push without stealing from its neighbor. Balance at the invisible level enables ease at the human scale. Consider the ledger again, closed, resting. In that image we glimpse the mystery of scientific continuity. Ink stops but meaning migrates. Dalton's pen fell silent in 1844. Yet every balanced equation, every mass spectrometry readout, every carbon dating curve hums with his premise. Even the digital models now forecasting climate change rely on partial pressure equations that first took shape beside a mercury trough. Across the Atlantic, deep in a clean room lit by laser panels, technicians fabricate graphene membranes 1 atom thick, counting carbon hexagons with scanning microscopes. They may never speak Dalton's name, yet his integer whisper steadies their hands all the same. Now broaden the lens beyond science. Think of art that absorbed chemistry's certainty. The Impressionists grinding pigments with measured calcium carbonate, the stained glass artisans calculating flux ratios for cathedral windows, the vintner testing grape must for sugar content so fermentation proceeds in stoichiometric grace. In turning chaos into craft, they echo Dalton's heartbeat. Even music pays homage. The equal-tempered scale subdivides an octave into 12 steps, each ratio tuned so that consonance prevails. Those steps mirror his insistence that freedom of combination thrives only when the units are constant. Shift again, this time upward, past the roof, through drifting particulate haze, into the night sky. Stars stud the dark cloth, each a furnace where hydrogen atoms merge, releasing pearl-white photons that sail for millennia before brushing Earth. Fusion, too, obeys countable unions. Proton meets proton, 4 into 1 helium nucleus, energy tally balancing mass loss. The integers hold beyond our planet, beyond our era, wired into cosmic architecture. Dalton spent little time on astronomical speculation, but had he known stellar alchemy, he would have smiled at its arithmetic pedigree. Trace a single photon rushing from Betelgeuse, scarlet to most eyes, muted brown to Dalton's, entering our atmosphere, scattering once, twice, then striking the copper coil of a photovoltaic panel on a silent Martian rover. That rover estimates atmospheric pressure by the partial pressure sensors nested in its belly, calibrating them according to Dalton's creed. It may be 600 million kilometers from the desk at which we sit, yet when it beams telemetry back to Earth, each data byte reaffirms that invisible engines run the same wherever atoms congregate. Return now to the study. The ledger grows heavier in the mind, not because its paper adds mass, but because awareness of its echoes amplifies its gravity. Set it gently atop the desk. Sense the finality of that motion. Knowledge recorded, preserved, respected. A faint vibration passes from your fingertips into the wood. Perhaps the wooden spheres shift ever so slightly in their box, a quiet applause for being remembered. Let your breathing mirror the order inside the ledger. Inhale calmly, counting silently to 4. Pause for a soft moment, then exhale to 6. Feel how the lungs comply, alveoli opening like pages, closing like covers. While you breathe, nitrogen atoms drift in and out, indifferent to the carbon dioxide atoms leaving their posts. Each species shoulders its own share of pressure, a democratic accord requiring no enforcement beyond the laws of probability. That accord cradles every living creature, from the whale broaching a polar sea to the hummingbird sipping dawn nectar. Visualize those atoms as lanterns the size of fireflies, glowing in delicate hues invisible to the human eye. When you inhale, tens of sextillions of lanterns stream down branching tunnels, each lantern containing its private flicker of kinetic energy. When you exhale, a nearly equal number depart, their glow unchanged, their journey continuing into the room. Some drift upward, collide with the ledger, and pause on the page where Dalton last wrote barometer 29.92. Sky fair, wind east-northeast. They settle for an instant, then rise again, swirling among motes of dust the morning will reveal. Now, gently dim the inner lights. Visualize extinguishing lanterns one by one, not their physical essence, only their brightness in your awareness. First the room's corners fade. Then the shelf relics withdraw into dusk. Finally the ledger's outline dissolves into a soft gray wash. What remains is rhythm, heartbeat, breath, the cosmic metronome of integers counted by stars. Against that backdrop, let thoughts slacken, like ropes coiled on a dock after the ship has sailed. If stray worries bob to the surface, errands unfinished, messages awaiting reply, imagine pressing them into the ledger's blank margins, where numbers will keep them safe until morning. Dalton trusted margins. He filled them with future questions while attending to present tasks. You can do the same. Note the concern lightly, then close the cover on it, knowing the ledger's discipline now guards your peace. Outside, the eastern sky begins its slow alchemy from iron to pewter to the faintest shell pink. None of these shades would have impressed Dalton's colorblind eye, yet he would have measured their arrival with pleasure. The temperature uptick, the vapor spike, the pressure nudge. Let those incremental changes soothe you. Dawn is a reaction proceeding in perfect stoichiometry. Sunlight recombines night and atmosphere into day. Needs no help, no supervision. You stand, or rather recline, on the threshold between sleeping and waking, just as the planet rolls from shadow to light. In this liminal hour, trust that every silent engine will continue to turn. Electrons will orbit nuclei. Nuclei will hold fast to atoms. Atoms will obey gravity, and gravity will keep oceans pinned to basalt beds while you dream. There is grandeur in that assurance, yet it asks nothing of you except surrender to rest. Before you yield completely, offer a brief, private nod to the man who made such trust easier. Not to the statue in Manchester Town Hall, not to the ceremonial fellow of learned societies, but to the boy scribbling due measurements before his first cup of oats. He could not have foreseen Mars landers or PET scans or the spectral fingerprints of exoplanets, but he sensed that nature plays by rules, and he proved that a single diligent observer can coax those rules into daylight. May his steadiness lend weight to your own quiet moments of inquiry, whatever shape they take. Now let the final lantern dim. With eyelids resting, feel muscle fibers loosen, jaw unclench, shoulders drift earthward. Breath slides effortlessly in and out. Thoughts fragment into gentle embers, flaring then fading against an infinite velvet. Somewhere far away, a weather station pings a satellite, a chemist zeroes a balance, a child counts marbles and discovers that 2 + 1 makes 3. Ratios hold. Order endures. You are free to drift. Slip deeper, until even the concept of slipping dissolves, leaving only the serene drift itself. No story remains to tell, no integer to tally, no ledger to close. Yet in the quiet folds of sleep, atoms continue their ceaseless dance, keeping perfect time. When morning gathers its light and brushes your eyelids, you will wake refreshed, supported by the same invisible engines that guided John Dalton. Until then, rest, carried gently by the promise that the universe, at every scale, remains beautifully in balance.